Let's look at mixed problem sheet number 10, which says that the sum of two digits of a two-digit number is 12. So we've got two digits. Let's say that this number is x and this number is y, and this is a two-digit number, so x can be 1 to 9 and y can be 0 to 9. So the sum of the digits is 12. That's an easy equation to make. So that first equation we have is x plus y equals 12. The next part of the problem, number 10, says if the digits are reversed, the difference between the new number and the original number is 54. So let's think about this. If the digits were reversed, so if it were yx, then the difference between the new one and the old one, the original one, is 54. So let's think about the values of this. Really, y, it's in the tens column, so I'm going to write tens. And x is in the ones column. And over here, the original number, x is in the tens column and y is in the ones column. So we have to think about that this value, that this represents, like if it's a 3, let's pretend x is a 3, that really means it's worth 30. And if this was a 7, it's worth 7. Whereas if we flip the places, instead of 37, it becomes 73, then that 7 would be worth 70. So we just have to think about how place matters because it's in the column. So let's use this information. The difference between the new number and the original is 54. So the new number, well, this y value is worth 10, so I'm going to write 10y plus, really it's like 1x. That's the new number. Minus, here the x is in the tens column, so it's 10, actually I should put this in parentheses, 10x plus 1y, that's the old or the original number. And the difference based on is 54. Okay, so we can solve this. Let's do this. This just means that we've taken the two digits and figured out their value. And then we subtract the original number. So let's rewrite the problem. 10y plus 1x minus 10x minus 1y equals 54. Let's see, let's get like terms together. 10y minus 1y, 9y, plus 1x minus 10x, negative 9x equals 54. I can actually make this a smaller equation by dividing everything by 9. Or I can leave it as it is. And I don't really care how you do it. I feel like I should solve the problem in two ways. So let's just use substitution at this point. We knew that x plus y was equal to 12, so we could change that equation to y equals, or x equals, but I'm going to go with y equals 12 minus x. So I can plug in 12 minus x where I see the y here. So 9 times 12 minus x minus 9x equals 54. We distribute 9 times 12, 108, minus 9 times x minus 9x equals 54. Give me 1 second. So I'm just confirming that 9 times 12 is 108. 12 times 9. Oh, phew. Okay, so let's see. Minus 9x, well, that's like subtracting 18x equals 54. We're going to subtract 108 from both sides. You might have done this differently. This is just how I have the numbers organized. 108. So negative 18x, don't forget to bring down that negative, that minus sign, which becomes a negative, equals 54 minus 108, which is negative 54. And then we divide both sides by 18, negative 18. So x equals, it should be like 3, right? A negative divided by negative is a positive, x equals 3. So what do we know? If x is 3, then y is 9. So that original number is 39. X, y, 39. So that's the original number. And if they were flipped, 93 minus 39 is 54. Now, if I'd taken this equation and just, if I'd done it a different way, I could have been like, 9y minus 9x equals 54. I can just divide everything by 9, like every term. Anything divided by a plus, a minus, or an equals. So that becomes y, 9 divided by 9, minus 9 over 9 x, because the 9's cancel, And 54 divided by 9 is 6. So suddenly, we end up getting, this is one equation, and the other equation was x plus y equals 12. Well, that's the same thing as y plus x equals 12. I hope you know that. So one equation is y minus x is 6, and one equation is y plus x equals 12. So I could just use elimination. I wish I hadn't made clouds around that, but it's okay. So if I'd added these two together, the x's cancel, eliminate. I get 2y equals 18. Oh, y equals 9. So I would have gotten, sorry about that, I would have gotten the same answer had I reduced the equation to begin with or not. So it just, I just want to reinforce that. Sorry about this. I don't know if it'll fit. I just want to reinforce that we have options. There's more than one way to do it, and we're just playing with the numbers. So we can talk about this more if you like.